Okay, got a real good case study here. This is a 2001 Chevy Impala with a 3800 engine. And the trouble code that we're dealing with is a 1404 EGR valve position error closed performance. This is a linear EGR valve. It has 5 wires. It's electronic. Uses magnetic field strength to control valve position. And then internal to the solenoid, which is the outer 2 wires, the middle 3 is a position sensor that tells the computer the exact position of the valve, and that is a potentiometer. Just get you a quick shot of the trouble code that we're going after here. There's a few other codes in this. There's an evap code and something else too. We're not worried about that for this video. We're just going after the EGR one, this P1404. Okay, so the next part of this video that I want to show you guys is what I would do with this code on this particular car, which is a GM. So not all cars are going to offer you this option, but what I'm going to do is I'm going to go back to my functional tests, and what this is going to allow me to do is to command this EGR valve to open and close. So I really don't need to do running tests. I'm really not worried about a plugged up passage like in some of my other videos for this code. It's not a flow code, it's a position sensor code. So go to my EGR, and what we want to look at are certain parameters here. In fact, I'll customize this to make it better to look at here. These are really the main ones we want to see. Primarily what we're looking at would be this EGR error, which is 12%, and then EGR position, which is also 12 to 13%. The valve is closed right now. The command is 0%. The valve should be closed. So right away we're seeing a problem here, that this valve is actually 13% open, and it shouldn't be. My voltage of 0.92, this would be the EVP signal, that's EGR valve position. The signal is at 0.92 of a volt, where you see the EGR closed voltage, what the computer expects to see with the valve closed, is 0.45. So some of these can be confusing, these abbreviations. This EGR FBK, that's EGR feedback. That's just telling you that's the feedback signal for the EGR valve. Or in other words, that is your EVP signal. So this 0.92 is too high for a closed valve position. And I'm basing that off of this percentage. Now I don't know exactly what the voltage should be. Again, I have this as a guide, but I don't like this 12 to 13%. It shouldn't be there. And this is showing you that as far as the error goes. So what I want to do now is I want to watch the valve the rest of the way through. And the nice thing about a bi-directional tool or a bi-directional scan tool is we can do things like this. So I'm going to hit test, and now what I'm going to do is I'm going to command different percentages. So starting up here, this is showing you what you're desiring percentage wise, not duty cycle, and we'll talk more about this in a minute. So I'm at 0, I click on this, and now I'm at 10, and what you see is we're still at 13% over here, and our EGR duty cycle, this will be what the computer is commanding the valve to do, is still at 0. The reason behind that is our valve was already more than 10%. So you see the desired now for us is 10% open. We're at 13% open. So the offset or the error is only -3 right now. Let's go further. So this next one is 20. And you see at 20% that we actually have a command, and that command of my EGR duty cycle is 28%. That gives me a valve position of 19%. I want a desired position of 20. I'm okay with these being a percentage off. So this is where I want the valve, and this is where the valve is, and our error is now gone. We go the rest of the way through that. There's 30, and watch over here. This 29, we're at 30, so these two are looking good. The valve is moving. You see our position sensor signal voltage is also rising, telling you the valve is opening. Continue. Here's 40. EVP voltage increased again. You see valve position open at 39%. Again, my error looks good. Keep going. There's 50, 48, 50. I'm okay with that. See the voltage rise. There's 60%. That's where we want the valve to be open, is 60%. You see we're at 58. And again, 2.5 volts would be 58% open. 70 and 68, you see the voltage is rising. Again, I'm going to go up to 100 now. There's 100% valve opening. We have a 97% EGR position. I'm okay with these numbers. The computer's actually okay with them too. You see the error is 0%. Our EVP signal is at 3.8 volts. And our EGR duty cycle, this would be the amount of magnetic field strength that we want, you could say, or the amount of on time of the EGR solenoid is 58%, is giving me a 100% valve opening. And I'm going to talk more about this here in a few. So I'm going to go back down to 0 now. And you see when we get to a closed valve position that we have our problem that's back. And what this is suggesting is that there is carbon actually on the seat of the valve, and that carbon is actually holding the valve off of the closed position as far as what the computer wants it to be at. And I think what we need to do next is pull the valve, and I want to show you how to clean the seat. Okay, before we do the fix on this vehicle, I think I want to take this opportunity to teach you guys a little bit more about duty cycle and output solenoid. So we're looking at the EGR valve in this diagram, and you see this picture right here that we have a 2-wire solenoid and a 3-wire position sensor. And one of the things that I've told you guys in section 3 of my book is to look at the solenoid and follow the wire that doesn't go to the computer, and that will tell you what circuit design is, whether or not it's power or ground side control. To give you a little bit of an example of that, I just drew just a quick picture on here, and what I'm showing here would be a solenoid, a coil of wire, typical insides of a computer. There's nothing listed here, maybe just what the valve is as far as control, like EGR solenoid. And you see that if it goes to a fuse on the other side, then it would be ground side switched. And then down here on this one, if it goes to a ground external, it's power side switched. So you guys have been following along, that's section 3 in my book. Now this one is a little bit unique in that both wires to this solenoid go to the computer. And one of the things that I've said is if both wires go to the computer, circuit design on a wiring diagram is really not possible. And that's what we're looking at on this design, is this, what I have highlighted pink here, this red wire goes to the computer and it says EGR valve control. So on most solenoids, that would mean that this other wire is going to go to either a fuse or go to a ground, but in this case, following this wire, it actually goes to the computer too, and it's gray-black and it says EGR control. So what that means is both wires, like I have on my generic diagram, both wires are going to the computer. Now one of the things that I've found is when both wires go to the computer for an output, they're generally power side switched. And I'm trying to think if I've seen any that are like this design that were ground side switched, and I have to be honest with you, I haven't seen any. So I don't want to say all. I hate the words all and always and never, because in this field, you guys know that doesn't happen. But from my experience in this circuit design, this is going to be a power side switched EGR valve. And GM has changed it. They actually used to, on the same linear valve in the older years, it was this design. It was ground side switched. This one is actually power side switched. So this pink wire, or what I have is pink, it's actually red, is the computer's control wire for the solenoid. So what I'm going to do is I'm going to T-pin this red wire and show you what this signal looks like while I am turning the valve on with the scan tool. Okay, just a quick shot of the EGR valve and my connection. I have my yellow lead connected to that red wire with a T-pin. See what that signal looks like. Okay, just to give you a little perspective of what we're looking at here, the scan tool is to the left here and the scope is to the right. And to be able to do this on the Verus, I know some of you have asked me how to do this before, you actually have to pull up your scope in a different window, and the only way to do that is you have to go under the component test meter first, and then you're given the option to click on the meter tab and click it again. I think you click it twice, and what that'll do is that'll give you a box that actually is able to be minimized. So let me zoom out here and show you. So you see down here it says scope view, and now what that allows me to do is have the scan tool pulled up, and this would be the full screen of the scan tool, and play around with it. You'd have to move your margins in, which are a little bit tricky to do at times, but then when you pull up your scope tab, you can look at them both at the same time. So that's what I'm doing. So I'm showing you scan data and live duty cycle control on this scope screen over here. So this is going to be my power side switched signal to this valve. This really isn't related to the fix, which is an offset. We have an error of 13% with the valve closed. This doesn't address that, but I think it's really important to understand what this duty cycle number percentage actually means. So if we look at this, when I turn the valve off, as you can see, there's no signal here at all. Turn the valve on, and I see 10% is my desired percentage, and you saw that signal kind of appear there for a second and then turn off. Well, the reason that happened is because of this error, that the valve desired position for this test was 10%. So the computer initially said, okay, I'm going to turn the valve on, and you saw that happen, but then the computer's looking at the position of the EGR valve to control it, and you see that it shut it back off because we were already at more than 10%. So that's what's going on here, and that's why the duty cycle percentage actually dropped off. So now I'm going to go 20%. And what you're going to see is this signal come back, and so that's what you're looking at here. And this on-off pulse is what is controlling this EGR valve. Now a little bit about this signal. This is a duty cycle, and what this means is, in this case, for this setting, that 28% is my desired EGR percentage, and that means that 28%, that's my on time up here. How do we know that this is the on and this is the off? Sometimes it can be backwards. This can be off up here and this can be on down here. The reason why the upper portion is the on section is because this is power side switched, and that's what determines that. So again, section 3 in my book. So the top portion, we're talking about 28% on, and that means the bottom section would be, if my math is right, 72% off. So duty cycle is a measurement of the on time within one cycle of this signal. So we're looking at 28% on, 72% off. So if I go, I'm going to go a little further here. Well, we'll talk about the 30% for a second. You saw that this increased and this decreased, which would make sense. It's a percentage. That my EGR duty cycle, that means the amount of time we're going to turn this valve on at 30% achieved a 30% valve position. Now, one of the things that's confusing with this at times, with other components especially, is that when you look at the EGR duty cycle percentage, you think that that's the valve position, but it's not. Let me show you a little further. I'm going to go 40. So there's 40% position, 36% duty cycle, and you can watch this change as I'm doing it. You see the on time is increasing. So now we're at 50% valve position, 40% duty cycle. Let's go further. There's 70% on. Sorry, that is not 70% on. See, I'm even getting screwed up here. This is 48% on is achieving a 70% valve position. I'm going to go to 100 now to make my point here. For actually, a little other teaching lesson here. You see this trigger up here and how it's moving on me? Let's pull this trigger down into a better range here. So to achieve a 100% valve open on this valve, which as you see it's 97%, it's close enough to 100. To achieve 100% valve opening, it only takes 59% duty cycle to achieve that. So here's what we know so far. The duty cycle command of something does not equate to the position of that component. For example, I just did a Ford with a minimum idle issue and a idle air control problem, and I told you guys in that video that at 19% the valve is fully closed. And that's typical of Fords. If you only turning the valve on 19% of the time, duty cycle, that's so weak of a magnetic field that the valve doesn't open. And at 60% duty cycle, the valve's fully open. So you see again, that duty cycle does not always mean position. So what is this? This is a percentage of on time to control the current flow through this coil of wire. Now, why not, for 100% valve position, why not just turn the solenoid on? Well, the answer is, it doesn't need to be on 100% of the time to achieve a 100% open position. In other words, if I were to turn this valve on any longer, all I would be doing is creating heat and using additional current flow needlessly. So there's no reason to burn up the winding. There's no reason to add extra heat, so there's no reason to go any higher than this. This was a design feature that 59% on this vehicle is going to fully open this valve. So what we're actually doing with this is we are strengthening and weakening the magnetic field by changing the on time of this signal. And when we weaken the magnetic field, the valve's going to close more. And when we increase the magnetic field, the valve's going to open more. Now remember that the magnetic field is going to be opposing spring strength. So it has a spring that closes it, has a magnetic field that opens it, and it's a blend between the two. So this valve is actually not being turned on and off from a sense that the valve is moving open and closed. It's the current flow that's being applied and stopped and applied and stopped. And really what's happening is this magnetic field never fully collapses. So it's kind of a blend between the on and off time, and it's a magnetic field expansion and contraction. And we're never really allowing the valve to fully close. Okay, to go a little bit further with this, I think it's a good lesson with duty cycle, pulse width, frequency. Now we'll leave pulse width probably out of this one. Is what is the operation of this valve? And I'm going to have to change the scales here to show you that. Okay, I had to pull up a different meter to do this. So what I just did is I pulled up a frequency, a graphed frequency scale. I'm going to drop this down. go to 500 hertz so we can see this a little bit better. And what we're looking at here, if you look right here, this 128.4, that is the cycles per second. If you look at this, and I'll change my duty cycle here at the same time we're watching this. It's a little tricky to do this. Okay, watch this number right here, this 128.4, that's the cycles per second. I'm going to change this duty cycle. So this will be off, and what we're going to see with the signal off, of course my graphed frequency is going to go away. And as I increase this signal, so there's 10, 20, 30, 40, 50, 60, 70, 80, and so on, you guys can see that we're staying at 128.4 cycles per second. So that little square wave you were looking at on that other screen is occurring at 128.4 cycles per second all the time. Let me go back to that now. Well, hopefully you guys just follow what I did there as far as configuring this. But now you see that this signal, again, I mean, you really can't tell that from here, that this signal is occurring 120, what was the number, 128.4 cycles per second, but it is. And what you need to understand is within each cycle of this signal, we have a variable duty cycle. So duty cycle is a percentage of on time within one cycle of this signal. That means from a rising edge to a falling to a rising, that would be one cycle of this signal that our duty cycle relates to that, not the frequency. Why 128 cycles per second? Mechanical engineer gets with the electronic engineer and they say, hey, this is a good frequency to operate this valve at to stay away from harmonics. There are harmonics in electronics, there are harmonics in mechanical things, and they just chose 128 cycles per second as a good control for this valve. So the valve is actually being turned on and off 128, I think that's the right number, 128 cycles per second. Forgive me if I'm off on that number, but you get the idea. This thing's being turned on and off over 100 times per second. Does that mean the valve is opening and closing 100 times per second? No, it does not. What it means is that this valve magnetic field is being turned on and off over 100 times per second. But the valve field is never really fully collapsing. So it's the current flow, if you want to call it that too. It's the current flow that's being switched on and off over 100 times per second. Not the valve itself opening and closing that fast. And this is how we're controlling the magnetic field. We turn it on, it starts to expand. We turn it off, it starts to collapse. And we never really truly allow it to fully collapse. So again, as I'm changing my duty cycle, you see my on time up top is my on time in this case is decreasing. And if I command the valve to open more, you see that that is being done not by changing the frequency on this valve, but by changing the duty cycle. So within each of these pulses we have a percentage change. Okay, last comment on this, just to review, and hopefully you guys learned something from this. But last comment for this, to review what some of the things we were talking about, is the duty cycle, whatever command that we're going to apply to a solenoid to turn it on, the command for duty cycle, which in this case is 56%, does not equal the position of that component. You see the position of this component is 80%, well 78 to be exact. At 57% duty cycle, this valve is open 80% of its position. So again, to review that, I used to think that duty cycle percentage would equal the position of the valve, especially when it relates to forward idle air control valves, and it just simply is not. So let's get that out of our heads. This is magnetic field strength and this is position, and they do not match each other all the time. Now, of course, you saw back here there was a time where it did, but that doesn't mean that in all positions they're going to match. At a 32% duty cycle, I have a 29% position or a 30% position, so they pretty much match at that moment, but that's more of a coincidence than it is a norm. So hopefully that makes sense. A little bit more on duty cycle. We'll leave pulse width out of this one. This is just a duty cycle control device. Mainly for this one, the reason we're not worried about pulse width is this one has a set frequency. No frequency changes, so we're just going to measure the duty cycle. Okay, now back to the problem at hand is our closed position being at 12%. And I don't like that at all. So the next thing that we're going to do is unbolt the valve, and we're going to look at the seat area of this Pintle and see what it looks like. Okay, hopefully I can show this part. What I'm concerned about is the seat area in here, and I've had some success with these in the past. So I have the valve out of the car, obviously, and what I want to do, let's get some light on here too, maybe that'll help. What I want to do is I want to actually push the valve open, and the seat area right in here, let's see if I can show it on the camera here, I'm having trouble. So push this down, and right in here there are carbon deposits that build up. Hopefully you just saw that chunk come out of there. See if I can show that. See the clean part and then the black stuff next to it? I hope that shows up. Can't tell with my small camera screen here. Gotta be careful I don't mess this gasket up. We're gonna reuse it. So I'm gonna go all the way around the seat and get this carbon off of here. And what we're hoping for is that this allows the valve to close more, because I believe that this is what our problem is. Now, some of these would also stick internally, and that is not our issue with this one. This one's not sticking inside. For the ones that stick inside, you can actually take this and spin it as you're moving it up and down, and that doesn't change the position of the Pintle. That just spins the whole plunger inside, and that's where carbon deposits occur. I've shown this in another video, kind of cleaning this. It was in a EGR flow video that I shot on a GM. Just trying to clean this area as well as I can to let this valve close as much as possible. So now what I'm going to do is plug it back in and see if we have an improvement of my closed valve position. Okay, I'm back to the scan tool. Got the valve still unbolted from the car, but have the electrical connection plugged in. And I got to tell you guys, this is not a fix. This made no difference whatsoever to our too high of a valve position or too open of a valve position with the valve commanded off. You see I'm still at 12% and my feedback voltage is still 0.9. It's fluctuating a little bit. So I'm at 0.9 of a volt. So now we got to go a little further. This is where section 7 is going to come in, potentiometers. We have a 5 volt reference, a signal, and a ground. I'm concerned about my potentiometer signal. My next step is going to be I'm going to compare the actual signal to what the scan data is showing me. Remember that this is processed data. We could have an issue here. And what the guy told me is he put 4 different EGR valves on this car and he continues to get the same code. So it is possible he's getting the wrong valve. He's going to a salvage yard. Maybe this valve is off of a different year and they're calibrated differently. That the closed valve position on the cars that he's been getting these off of use a different range. That is very possible. That we just need to get a valve. But what we need to do to be 100% is we have to do our wiring checks and make sure. If our wiring comes out good, then we're going to tell him to get a new EGR for this and stop going to the junkyard. So let's see the result of the next part of this. Okay, I'm going to hopefully be able to show you both of these and what I'm doing. I still have the valve unbolted. I don't need it bolted up for this part. Some of this is just fundamental test. This is a potentiometer. So we know that potentiometers have a 5-volt reference, a signal, and a ground. And I don't know what's what. I mean, I have a wiring diagram, but I don't really need it. What I can do is go down the line. I'm going to start with this gray wire and just get a reading of it. And you see on my screen, hopefully that'll show up, that that's a 5-volt, 4.98 volts. So that would be a good 5-volt reference. Moving down the line, I'm in the middle wire now in this whole assembly. And this middle wire, I'm reading 0.88. Most likely that is my signal wire. If you remember on the scan tool, it read 0.9. Last one being my sensor ground. We want around 100 millivolts or less. And generally speaking, you're going to be less than 10 millivolts on a good ground. My key is on, and I'm reading negative 0.01. So there's nothing wrong with this ground. And I'm not exactly on the battery. I should be for this test, but that might explain the negative voltage there. But there's nothing wrong with this sensor ground. I'm going to go back to the sensor signal again, which is this one of 0.88. One of the things that we want to do, and I'll get you focused on the meter so you see it a little bit better. Alright, so what we have so far is we have a good reference, we have a good ground, and we have a signal that looks like it matches scan data. So what we want to do is look at the signal, and we're reading 0.88 of a volt, and we want to compare that to what the scan tool is reading. We're reading 0.92 on the scan tool. Let me pull up both together here. Alright, so scan data, so that's showing up. Scan data over here of 0.92 and actual signal voltage of 0.889. So basically 0.9 and 0.9, there is nothing wrong with that signal. They are very close to each other. A few millivolts difference is not an issue. I don't have a problem with that. There's no way that that is going to be an issue with wiring, and what my suspicion is that this is just the wrong valve for this car. I mean, he's been going to a salvage yard. I think I have enough info here that I'm going to tell him to get me a different valve, and I'll make sure that I have this in this video. I don't see a reason to attack the harness. What I would be concerned about is, let's say that at the sensor itself I had a 0.5 volt, and at the computer I have 0.9, that would be enough to give me an issue or make me concerned about a wiring problem. But I'm reading basically 900 millivolts at the sensor, and I'm reading 900 millivolts on the scan tool. There's nothing wrong with the wiring to this valve. I'm going to tell him to put a new valve in it. Okay, I just called this guy because I am concerned that he put 4 different valves in this car and it's not fixed. And what he told me is the other 3 valves that he had on this car are in the driver's or on the passenger floor. So I have all 3 valves. I'm going to show them to you. I'm going to plug each one of them in. Actually, the one that I have in here now is off of a 94 Jimmy. And you see it's still reading 7%, so it's better than what we had. And it is clean. I tried cleaning the Pintle on that one. Really no change there, no difference. This would be the original valve that he had in his car, is this one. And, or no, that might be the one that's the one that we had in there for the start of this video. That 13 or 12%, and cleaning this didn't help us. This would be off of a 2000 LeSabre. And you see this one's 6%. The best I can do is 6% there. And then the last one he had, this would have been his original valve, but this one was dirty and carboned up, and he cleaned it and put it back together, but you see we're still at 9%. So I don't know if this is going to fix it, but it's worth talking about. And with 4 different valves, me not being able to achieve a 0% closed valve position makes me concerned that I might be missing something here. And I have to tell you that what would fix this thing would be if we could somehow tell the computer that the EGR closed valve voltage position of 0.45, if we could somehow tell the computer that, hey, it's not 0.45, it's 0.7 or 0.8. And I think, what happened? Just lost my communication. Well, that's because my battery's dying. I'll bet you, try to crank it real quick. Yeah, I killed the battery is what happened. All right, we need to get a jump pack on here. All right, well, I got power back on this thing, and I'm really upset right now because I blew the opportunity to really show you the fix for this vehicle. But as you can see, my EGR feedback signal, I'm still at 0.7, 0.8 of a volt. This is the last valve that I had on there right before our battery died. But I want you to notice that the EGR closed voltage position number, this 0.76, is now different from before. It was 0.45. So, the issue with this vehicle is that EGR closed voltage position is learned by the engine computer. And what it does, as soon as the computer powers up, this will be initial power up, computer's going to look at the EGR valve. Just lost communication here again. Okay, we have communication again. My battery did go dead, and unfortunately, in the process of this battery going dead, this car is now fixed. And what I wanted to show you guys, and this is where I was going to take you, was we needed to disconnect the battery to reset this EGR closed position voltage value. So if you look at this top left number, this 0.76, before this battery went dead, it was 0.45. And I think this is a lesson learned for all of us, that when you're replacing components, certain things need to be reset. And in this case, on this vehicle, the only way to reset the closed valve position voltage that the computer wants to see is to disconnect the battery. If you have the key off, that's not doing it. This is maintained in a keep alive memory. And you can see that what I was going to show you guys was, at this point right here, I was going to disconnect the battery, come back to the scan tool, and show you exactly what we have. I didn't change the valve from the last capture before this thing went dead. And if you look at the EGR feedback of 0.7, 0.8, that's where we were. And notice now the EGR position is now 0. The EGR duty cycle, sorry, the EGR error is now 0. This is what we want. So here's what I think. I think the car has been fixed for a long time, all these valves that he's been putting in here, but we never disconnected the battery to reset the learned number that's in there of 0.45. Now, some of you might be thinking, well, where'd the 0.45 come from? Because 4 different valves, the lowest value we're seeing is 0.7, I think was the lowest we saw, 0.68 on one of them. I can't answer where that 0.45 came from, but here's a lesson on this, and I've seen this with throttle position sensors too, where the computer wants to see a certain voltage, and it's a non-adjustable TPS, and you have to disconnect the battery to reset that learned minimum TPS. It's the same thing with this car. In fact, I have a case study on this in my book in section 20, idle air control systems or idle speed controls, where this vehicle, I can't remember which page, you guys that have it can refer to it. This vehicle had an 1800 RPM idle speed from this exact same scenario that the battery simply needed to be disconnected to bring that idle speed back down to a normal range. And it was from the same kind of thing. So this is a memory. Think about this. This top left number up here at 0.76 is now reset or relearned. That is only done one time, and that's initial key on after the battery's been disconnected. It's the only time that's done. There was no other way to reset this. Clearing trouble codes or none of that fixed this problem. This car, really what it needed was it needed the battery disconnected. After this valve, the original valve was probably carboned up. After the valve was cleaned, this needed the battery disconnected and reset that number. So I like that. I think what I'm going to do is I'm going to use his 2000 LeSabre unit that he got from the salvage yard, and then we'll recheck these numbers and make sure they look good. I might disconnect the battery one more time too. Alright, I got this 2000 LeSabre EGR on here. That was written on the side of it. Got the battery disconnected. See, we're hovering between 0.68, 0.7 on the EGR feedback, 0.67 closed valve position. That's our new relearned value. All my numbers are 0. This is great. I'm going to test it now. 10%. So with a 10% valve position, you can see that it took a 27% duty cycle to achieve that. We have no error here. I like that. Go further. 20% open, valves open 20%, 28%, 29% duty cycle, and so on. I'm going to just scroll through this, let you watch it. There's 30, 40, and that's percentage, not duty cycle. 50% open, 60. You see our numbers changing all the way through. This looks good now. We actually got a little bit higher voltage on this one from the other one. We got 4 volts. The other one was like 3.8, but still 97%, 100% open. Close enough. No error is my main thing. This looks great. Go back down to 0. And we have our closed position of 0.67, our closed position voltage of 0.68, 0.7. That is fine. We have no error. So lesson here would be, we replace components. We got to make sure we disconnect the battery. This was something that was absolutely critical, that the battery was disconnected so we can have this EGR closed valve position voltage change. Now the interesting part is these newer cars, usually just cycling the key off and back on is enough to have this relearn process take place. I'm not sure why it didn't work that way, but ultimately the fix was to change the valve that was sticking or clean the valve that was sticking open a little bit and then disconnect the battery to take care of this system. Now it could have been the original valve was faulty, and maybe that's where our 0.45 number came from, that thing was starting to fail and there was a new relearned number from that wasn't a good number. But this was a program issue. So very, very good case study as to why we want to disconnect the battery. Very good lesson on EGR valve position and the error. There's some other things that you guys might run into with these, and just one last comment and then we'll just wrap this up. This is too long as it was. So I've seen these before, that people will take this valve, this is one of the old ones, and they'll actually, on some cars, this one it won't, but on some cars this valve will actually bolt in both directions. You can bolt it on like this, or you can spin it and bolt it that way. And what I've seen is, if it's backwards, what happens, you should have vacuum on this side and exhaust gas on this side. And if you bolt it backwards, what you'll have is vacuum on this side and exhaust gas on this side. Now that might not seem like a big deal, but it is, because what will happen, vacuum will go into the chamber in here, and it will actually lift the Pintle off of its seat from vacuum. So the way that you recognize that is, what you'll have is normal closed valve position with the key on, with the engine off, but as soon as you start the car, you'll notice the Pintle position voltage will rise, and if you see that, that's a red flag that that valve was bolted on backwards. So a lot of different things that these can do. That was a good one. Hopefully you guys liked it.